In part 2 of our lesson on the trig form of complex numbers, you will learn how to convert from rectangular form to trig form. In this example, we have to express in complex trig form z is equal to 2 radical 3 minus 2i. So let's first graph this number in the complex coordinate plane. We know that the x value is 2 radical 3, so that's a positive. And the y value is minus 2. So that means our vector goes here. This will be r, and this will be theta. Using our conversion factors, we know that r is equal to the square root of x squared plus y squared. So that will be the square root of 2 radical 3 squared plus a minus 2 squared which is equal to the square root. We know that 2 radical 3 squared becomes 4 times 3, which is 12, plus negative 2 squared is 4. This is the square root of 16, which is 4. So we know r is 4. The tangent of theta is equal to y over x. So in our case, that is negative 2 divided by 2 radical 3, which is equal to negative 1 over radical 3, which we can rationalize. Multiply by radical 3 over radical 3, and the tangent of theta becomes negative radical 3 over 3. Now from our special angle chart, we know that the reference angle is going to be pi over 6, or if we're in degrees, then the reference angle would be 30 degrees. Now we have to be in quadrant 4. So if our reference angle here is pi over 6, then we know that theta in quadrant 4 has to be 2 pi minus pi over 6, which is 11 pi over 6. Or if we're in degrees, then theta is 360 degrees minus 30 degrees, which is 330 degrees. We know that the trig form is z equals r cis theta. So if we are in radians, then z is going to equal 4 cis 11 pi over 6. Or if we are in degrees, then z would equal 4 cis 330 degrees. In this example, we have to express in complex trig form z is equal to -4 plus 4i. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. So the real part is -4. The imaginary part is +4. Here is z. This will be r, and this will be theta. Using our conversions, we know that r is going to equal the square root of x squared plus y squared, which is equal to the square root of -4 squared plus 4 squared. (16 plus 16 is 32. We know that 32 has a perfect square of 16 in it, and the irreducible part is 2. So r is equal to 4 radical 2. We know that tangent of theta is equal to y over x. The y value is 4. X is -4. This reduces to -1. Referring to our special angle chart, we know that theta r is equal to pi over 4 in radians, or 45 degrees. Theta is in quadrant 2. So if we put the reference angle here in our picture, start at pi, and we back up by pi over 4, then we know that we would have theta equal to 3 pi over 4, or if we're in degrees, we would start at 180 and back up by 45, which means we are at 135 degrees. Trig form means that z has to be expressed as r cis theta. So if we are in radians, then z will equal 4 radical 2 cis 3 pi over 4. If we are in degrees, then z will equal 4 radical 2 cis 135 degrees. In this example, we will express in complex trig form z is equal to 2i. So this means that you could rewrite this as z is equal to 0 plus 2i. So then you know that x would be 0 and y is equal to 2. So that means our vector is here. We know that r has to be the square root of x squared plus y squared, which is the square root of 0 squared plus 2 squared, which is the square root of 4, which is 2. You could have also seen that from the beginning, knowing that r, of course, is the distance from the origin out to the terminal point of the vector. Likewise, it's pretty easy to see what theta is in the picture without having to do a calculation. But I want you to see that it would work out even if you did do the calculation. We know tangent theta is equal to y over x, which is 2 over 0, which is undefined. We know that looking at our picture, seeing that theta has to be on the positive y-axis, we know that theta then, if we're in radians, would be pi over 2, or if we are in degrees, theta is 90 degrees. We have to write z in trig form, which we know is z equals r cis theta. So if we are in radians, z is equal to 2 cis pi over 2. And if we are in degrees, z will equal 2 cis 90 degrees. In this example, we have to express in complex trig form z is equal to -2. Let's go ahead and check your understanding on this one. So pause the video, work the example on your own, then restart the video to check your answer. We can write this in standard form by setting it equal to -2 plus 0i. So we know that our x value is -2 and our y value is 0. So then here is our vector. This distance will be r. This angle is theta. And this is one of those cases where you can see r and theta immediately. But if for some reason you don't, or you're not sure, just apply the definitions. We know that r is equal to the square root of x squared plus y squared, which equals the square root of -2 squared plus 0 squared, which is the square root of 4, which is 2. And notice that r is always positive. Sometimes students will make mistakes and think that r is -2 because it's going in this direction. Remember that r is still a distance. It's the distance from the origin out to the terminal point, and that distance, r, is always positive. Using the definitions, tangent of theta is equal to y over x. We know our y value is 0. X is -2. 0 divided by -2 is 0. And since theta has to be on the negative x-axis, we know that theta is equal to pi if we're in the radian measurement system, or if we're in degrees, then theta will equal 180 degrees. Trig form is z equals r cis theta. So if we are in radians, z will equal 2 cis pi. And if we're in degrees, z will equal 2 cis 180 degrees. In this example, we have to express z is equal to 1 plus 5i in complex trig form. We will round our radian answers to hundredths and degree answers to the tenths place. So this will be a calculator problem if you want to go ahead and get your calculators out. First, we will want to graph z. We know that the real part is 1 and the imaginary part is 5. So here's the vector, that is z. We have to find r and theta. Using our definitions, we know r is equal to the square root of x squared plus y squared. So that's going to be the square root of 1 squared plus 5 squared. So that will be the square root of 26. So now we know what r is. Tangent of theta is y over x. So that's going to be 5 divided by 1, which is equal to 5. Now if we take the tangent inverse of both sides, so we have tangent inverse of tangent theta is going to equal the tangent inverse of 5. We get that theta is going to equal, now we need to make sure that our calculator is in radians mode, so we hit the DRG button, cursor under the radians, and hit enter. Now we do second tangent inverse of 5, and rounding to the hundredths place, we see that theta would be 1.37, or if we're in degrees, we put our calculator into degree mode, so go back to the DRG button, cursor under degrees, and hit enter. We've got tangent inverse of 5. And rounding to the tenths place, we get 78.7 degrees. Trig form, we know is z equals r cis theta. So if we're in radians, we would say z is equal to radical 26 cis 1.37, or if we're in degrees, we will say that z is equal to radical 26 cis 78.7 degrees.